Hello, everyone. Hi, my name is Eli Birger. I'm a CTO and co-founder of PerfectScale. Prior to establishing PerfectScale, I spent many years managing DevOps and infrastructure teams. I established large-scale SaaS systems, mainly based on the Kubernetes in recent years. And today I'm going to talk from my experience about a little bit about the autoscaling in Kubernetes, how to simplify and understand what the Kubernetes autoscaling is. But before we jumping into the mechanics, tips, and tricks of autoscaling, let's talk a little bit about what is autoscaling and why we would try to implement autoscaling in our environments. So basically, Kubernetes autoscaling is a problem of day 2 operations. What is day 2 operations? So any system starts with day 0. The day 0 is when we plan our system. On day 1, we're building our system, and day 2 basically is the constant effort of managing our, it's the continuous and endless effort of managing what we built. So cloud native systems coming with the great promise for day 2 is the flexibility. We can scale our environment up when it's needed. We can scale it down when it's not needed and save some money. So by that, we can achieve the holy grail, the best possible performance at the lowest cost possible. So let's dive into the autoscaling. When we're talking about the autoscaling or scaling in general, there is 2 dimensions to think about scaling: the vertical scaling and the horizontal scaling. The vertical scaling is when we're adding more resources to the existing instances, whatever it is. It could be a nodes, it could be a pods. And the horizontal scaling is when we're adding more replicas to the existing instances. So Kubernetes comes and Kubernetes and open source community brings us a few tools. Those tools are widely adopted and battle proven for horizontal scaling. There is a cluster autoscaler, AWS Carpenter, GKE Autopilot to scale your nodes automatically. There is HPA and KIDA to scale the pods horizontally. And with all those capabilities, for me personally, when I built my first system, it was obvious. Let's put the cluster autoscaler, let's put the HPA, and everything will just work fine, right? So that was my expectation, very high SLA, and my system is flexible, scaling up when it's needed, scaling down when it's not needed. My cost is kind of have those very nice seasonality waves, but the reality was a little bit different. What I found over time is that my SLAs are not so good in the spikes, and also my cost is constantly growing. So this was for me the point where I decided to dive in and understand a little bit more on how does it work. So let's start with the simple mechanic of scheduling in Kubernetes, because everything starts there. For the example, we are taking a pod with the request of 4 cores of CPU, 8 GB of memory, and some limit. It doesn't matter. And we will schedule this pod on a node. And for this purpose, our node will contain 8 cores and 16 GB of memory. So as you can see, when this pod goes to the node, it allocates certain amount of CPU and certain amount of memory. And this amount couldn't be taken by any other pod. When we will try to schedule the next pod, and for the example, we will take the pod with the request of 12 GB, it couldn't fit on this node. So this pod will become unschedulable. Cluster Autoscaler, Carpenter, Google Autopilot, all those are subscribed to unscheduled pods. They are watching for unscheduled pods. And if they see the unscheduled pod, they're going to pop and bring new node to the cluster, so we will eventually be able to schedule our pod. But the important thing, we haven't said anything about utilization. We are talking about the request. We requested 4 GB of memory, then we requested 12 GB of memory. We haven't utilized yet anything, but we already have 2 nodes running. Let's continue. So the cluster autoscaler. Cluster autoscaler is responsible for provisioning and deprovisioning of our nodes. As we discussed, the amount of nodes correlates with the requests of our pods. What about deprovisioning? How this part works? You can guess it works the same. It looks for the requests. And when particular node utilization goes down below certain threshold, by default it's 50%, it will deschedule the node, or at least it will try to deschedule the node. So once we understand this, let's see how the HPA works. So HPA, the concept is pretty simple. We want to increase the amount of our pods to increase the parallelization, and by that process more data. So the basic and initial trigger was the CPU or the memory. This is the most common one. And again, this one looks and compares everything to the request. For example, if we will take pod with the request of 1 GB of memory and limit of 2 GB of memory, and we will set our memory trigger to be 70%, the HPA will add additional replica at 700 megabytes, which is 70%. The HPA will deschedule this replica only when the average utilization of all the replicas will go below this 700, right? So another options to scale additional pods is based on the custom metric, like amount of requests per second or something like that. And KIDA brings very advanced capabilities. For example, you can schedule by event. You have, as your Kafka queue grows, you can it could trigger additional replicas. Or, very convenient one, there is a cron that you can schedule on. So for example, if you have development environment and you want to schedule this environment down during the weekends or nights to save some money, again, very nice. I also found it very useful in production where load ramp up is predictable, and I can in advance schedule additional replicas and not wait for the actual triggers. So now we understand all these mechanics, right? And basic building blocks, the requests. So how it's all come together in environment. So in some cases, it may play nice. In some cases, it may play not very well. It could create problems in terms of resilience. It also could create a waste. It's also nice to mention here the VPA, the missing part of the Kubernetes, the vertical pod autoscaler, the tool that promised to bring the vertical right sizing. However, it doesn't really work well. It doesn't support the HPA. It doesn't support the HPA. It's not battle proven in production grade. It relies on a decay histogram algorithm. I definitely do not recommend to use it if you have high seasonality waves in your environment. So I promised to simplify the autoscaling. However, as you can see, it's not very, very simple. The things that so let's try to look at the autoscaling from a little bit different perspective. The perspective of what actually could get wrong with our autoscaling. So first of all, let's talk about the pod requests. If we will over-provision our requests, what will happen? What will happen is we will simply waste a lot of money. And we will also create excessive CO2 emission. And you know, at the end of the day, we all share the same planet. And any impact that we can reduce is good. If we under-provision the amount of the requests of our pods, we will get SLA breaches, we will get different performance problems, we will have out of memories, we will have CPU throttlings, we will have evictions, our system will not be stable. If we will not define the requests, as you now understand, we will simply break the entire orchestration. The scheduler will not be able to schedule pods as needed. The cluster autoscaler will not be able to add right nodes, and yeah. So let's talk about the limits now. We spoke all the time about the requests. Let's talk a little bit about limits. So limits. If we over-provision our limits, limits acts as the circuit breaker. They are there to protect our node. What we would like to avoid the situation where a particular pod, busy neighbor, ate all the memory and cause a node failure, and could cause also a potential domino effect. So if we are over-provisioning our memory limits, we will find ourselves constantly firefighting dying nodes. If we under-provisioning our limits, what happens then? Then we will firefight dying pods, because our pods will not have enough memory on spikes, and on spikes they will just die out of memory, throttling, etc. And if we will not define, then it's actually hell happens, because we will firefight both the nodes and the pods and everything. Let's talk a little bit about common problems in cluster autoscaler. So first thing to consider is the right sizes of the node. If you're choosing the nodes that are too big, the result is huge blast radius. At the moment that particular node goes down, it takes with it a huge chunk of your cluster. If we're choosing small nodes, then what happens, it creates a lot of overhead. Each node will contain all the daemon sets. Each node will allocate your IPs. Many nodes will create excessive traffic between them. So it's everything about finding the right balance in your particular environment. But practically talking, DevOps is not only about technology, it's not only about metrics, it's not only about how the things are working, it's also about combination of technology and methodology. And when we are talking about understanding the autoscaling of our clusters and their performance, we need to think also about the process of how we improve that. So first of all, let's talk a second about the pets versus cattle paradigm. As a DevOps managers, or as a DevOpses, or as a platform engineers, SREs, we operate in terms of cattle. We oversee a lot of clusters with different workloads. However, each one of them is a pet. Monitoring solutions provide us with a very good visibility into the pet. If we know which one needs attention, we can grab all the data. Think how you can, first of all, evaluate your cattle and then be able to pinpoint the particular sick pet in order to fix it. Few more things to think about is prioritization. How you decided that your particular cluster is unoptimized and you want to improve its optimization. So how do you prioritize things there? Repeatability. Your clusters having multiple deployments a day. There is a waves of load that coming and going. It's constantly changing environment, and this work needs to be repeated. You will not finish it in one action. And to get best results of your attempt, you will need to collaborate. You will need to collaborate with your R&D and developers. You will need to collaborate with FinOps. You will need to collaborate also with and understand which cluster you're running, which cloud you're running, and how it's built. So last thing, this is a very, very simple dashboard. You can build this dashboard by your own, and you can also and you can also pull it from our repo. This dashboard brings you 3 values: the utilization, the requests, and the allocation. And this dashboard allows you to simply evaluate if your particular cluster optimized or not. Do you need to invest in optimization or not? If you compare your utilization and request, you expect that at least your utilization is covered with allocations. You expect that your requests are covering the utilization, and only spikes are going above the requests. And you can also evaluate how much you're wasting in terms of memory and CPU. Like if you're using only small chunk of your CPU and you have a lot of CPU up, you are just simply overpaying and creating excessive CO2 emissions. So thank you very much, and it's time for questions, I guess. Questions, anyone? What is the solution? That's a great question. That's a very good question. I like it. So, first of all, start with evaluating. Understand if you need to invest in that. In some situations, maybe, you will find that you don't have those seasonality waves and you don't need to invest at all. Like, everything is working fine. In some cases, you may come to conclusion that you don't need HPA at all. And it's worth to keep like 5 replicas running all the time and don't deal with the additional replicas going up and down because you're creating a lot of noise. In some situations, you will come to the conclusion that everything is fine, but in some situations, you will come to the conclusion that you need to improve. And this knowledge is like half of the answer. Any particular questions? Carpenter, cluster autoscaler, KIDA, HPA? Wow. All right. Thank you very much.